Yeah, somebody that doesn't like being perceived, that was very anxiety-inducing. So yeah, if you can hear my heart pounding through the microphone, it's either that or it's because I am an accessibility specialist and talking to front-end developers and whatnot tends to be a bit awkward at times. But yeah, I'm Craig. I'm an accessibility specialist at Technological. Previously, I've worked on gov.uk services, and I worked for Elastic. I tend to work at places where they do something very well, but they're maybe a little bit boring in terms of what they do. But yeah, I always like to just say at the start of the talk, like I'm autistic and I have ADHD, so the talk's either going to be like, depending on which side wins, it's either going to be like super erratic or it's going to be like really clinical. And I've had I got in at 2 o'clock this morning, I'm running on 2 hours sleep and Red Bulls and whatever, so I think it's going to be erratic, but hopefully it'll be all right. So yeah, AI is everywhere right now. We've heard it mentioned several times already today. Like you can't open a browser, you can't sit through a meeting, you can't attend a conference without somebody mentioning it. Sorry, like today I'm that person. But unfortunately, I don't think this one is going to go away. The ship has already sailed. Resistance is futile. ChatGPT has around 1 billion weekly active users, also it claims. Copilot is literally built into everything, even though none of us really want it. UI design is often getting done by Figma now, and around 14% of GitHub requests apparently involve AI agents. Like that can be detected. Obviously, all of us that are just using Claude and then pushing it and not saying anything about it, there's probably a lot more than that in reality. But I think for me, so my background's in design and development, but also obviously now in accessibility. And I don't think we are safe either. I mean, this is a slide from AxCon last year. This obviously is an accessibility specialist, made me a little bit nervous. They have this vision. Weirdly, this raised a few eyebrows and they deleted the talk, and you can still find the slides online if you go on like the web archive. But they put this slide up, it raised some eyebrows, and they deleted all knowledge of it. But they had this vision that they want 100% of accessibility development testing and fixing to be done with zero specialized accessibility knowledge using DQ solutions. So yeah, I think in terms of anxiety about AI, whether you're a developer or whether you're an accessibility specialist, we're all in the same boat now. And I've been doing this talk now for a little bit over a year. And I say this talk, it isn't this talk, because the landscape is changing that rapidly that every time I do the talk, I have to completely rewrite it from scratch because none of it's really relevant anymore. So there are some examples in here. Every time I give the talk, there becomes less examples, but we'll get to that. But yeah, the ship has already sailed, so should we use AI isn't the question we should be asking anymore. I then moved on to doing this talk and talking about, okay, well, it's here to stay, so how do we use AI well? So then I was like kind of talking about, okay, we can do spec-driven prompting, and we can do we can work with these tools and we can use agentic AI rather than just randomly prompting on the web and whatever. And then this has been the third iteration of the talk, which is now more, not how do we use it well, but what is the human cost of us using AI all of the time? I think we're all probably aware now of the financial and environmental costs of AI, but like what's the human cost? What is the web going to look like? A few years down the line when we're all just pushing stuff out with Claude or whatever. So when I give this talk, I do have a section in here kind of on how LLMs work. I suppose because we're a bit short on time, I'm going to say, is anyone in the room not aware of how they work in terms of probability and surprisal scores and that kind of thing? Or am I all right to just rattle through this section as quick as possible? I'm going to say I can rattle through this section. Okay, that's good. That'll give us more time to talk a little bit about some of the other stuff later on. So just to kind of quickly rattle through it. Yeah, LLMs do form responses based on probability. They are given massive amounts of data, books, websites, articles, all of this stuff, which is where all of the copyright infringement stuff comes in, but they're basically just trained on loads of stuff. They then break it all into billions of tokens. That could be a word or a syllable or a piece of punctuation or whatever. And then based on those tokens, it uses a surprisal score. So if we have a sentence like an elephant grasps a tree branch using its whatever, A trunk, it wouldn't be surprised to see, so it's probably going to put that in there. Hands, probably going to be quite surprised to see that, so an LLM is unlikely to say that. Obviously, when we're vague with our prompts, it becomes a lot harder for the AI to then produce things that are correct. If we just say people are looking for, could be love, could be work, could be elephants, we don't really know. And this is kind of how it writes code as well. So when you have an open and H1 tag, and then it needs to put a close and one on, in all of its training data, 99% of the time, it was a close and H1 tag that closed it, and therefore, that's the one that it's going to be least surprised to see, and it's going to chuck that one in. There is an element of randomization, so if many words score the same, it has to pick one of them, and obviously, it might not pick. Depending on when you use it, it might pick a different word and it might go down a different path. And we'll see that in some of the examples, but sometimes when it goes down a path, it becomes difficult for it to then get off that path. So there is an element of randomization, I guess. Every word that it chooses is a sliding doors moment where it could be wrong or it could be right. They do hallucinate, which is a nice way of saying that they tell you stuff which is not true. Apparently, we can't say that they lie, because that would imply they had consciousness and intent, so they can't deliberately manipulate you, apparently. But they do tell us stuff which isn't true, which in most cases we would just say, you know, they're lying or whatever. But it will tell you with absolute confidence the wrong answer quite frequently. So I guess at this point, they're probably just an average middle-aged white dude in tech sometimes, because, you know, we all do that at times. But yeah, LLMs, like, they're not consistent. They can't give you the same answer twice. They are generative in their nature. They can give you roughly the same answer, but it's very rare going to be verbatim the same answer every time. So we see people using LLMs a lot for stuff where an LLM might not be the best. You know, you might be better off with a lookup or something like Elasticsearch or whatever, but people are just using LLMs for everything. And the most surprising thing that people, I suppose, like, when I'm talking to people that don't know how LLMs work, they don't know facts, they just know relationships between tokens. And I think this is the bit that surprises most people. Like, if we say to an LLM, you know, what is the capital of France? It's always going to tell us Paris, because in all of its training data, every time it sees the capital of France is, the word Paris always follows, and therefore, based on probability, that's what it's going to give you. But it doesn't actually know where Paris is, it doesn't know where France is, it doesn't know any of that. It just knows the relationship between the tokens. And because of this, LLMs are biased. So based on all that training data, if you have a whole bunch of stuff that's written by humans who are inherently and historically biased, and you know, there's a whole bunch of inappropriate language in there, there's a whole bunch of cultural inappropriations in there, racist language, all of this stuff, and you give it to an LLM, it's then not surprised to see those things come back out when it starts to base on probability. It's like, okay, I'm going to regurgitate this information. Oh yeah, I'm not surprised to see that. That's fine, let's ship it. And it could be full of all of that human, that bias that's kind of baked into it. So now that we know how LLMs work briefly, this is a point that I'm just going to leave on the screen for a second. When we talk about bias, and I think Daniel touched on his talk earlier about how diversity makes everything better, people with disabilities are notably absent from LLM datasets. So they're often only trained to recognize humans in a particular form. This means that, obviously, there was the example of the hand soap from earlier, where, you know, an AI couldn't recognize somebody who was black trying to use the hand soap, but it's also things like voice detection. Voice detection can't always understand people who have things like cerebral palsy. Facial recognition can't always recognize somebody that's had a stroke. In pedestrian algorithms, you know, like if you're waiting at a traffic light and the traffic light's trying to intelligently work out if somebody's waiting at the crossing, they don't always recognize somebody in a wheelchair. They're looking for somebody standing on 2 feet in that kind of humanoid form, and they don't recognize somebody when they're sat in a chair. So all of these things automatically just become part of that bias because we train them with data on, like, this is what a human looks like. And humans obviously come in all shapes, sizes, and forms. So if the data is bad, the LLM's reasoning will also be bad. And this is the crux of everything, I suppose, with LLMs. The more bad examples that they have in their training data, the more bad examples they're relying on. And if the data is bad and the prompts are bad, then everything you get out will be bad. Like, essentially, if you get trash out, it's normally because you put trash in somewhere. So how does this all affect the web? Well, humans historically are really bad at writing HTML. It's a very, very flexible language. It's very forgiving. Like if you don't close a tag, the browser will normally just close it for you. And most people who, well, I say most people, a lot of people who get into HTML get into it, like I didn't go to university to study HTML or anything like that. I just started like, whacking out crazy designs for a MySpace page back in the day. And I was like, oh, I can totally just absolute position all of this stuff and I'll teach myself and whatever. So I think a lot of people get into HTML because it's quite easy to do, it's quite easy to teach yourself. And then they go on to build a whole bunch of stuff for the web, which is often not accessible. Like I've written some horrendous HTML in my time. I remember editing WordPress themes back in the day, and I was just deleting ARIA tags because I didn't know what they were. I was like, oh, there's an ARIA attribute there, no idea what that is, that can go. So I think we've all shipped HTML that probably isn't accessible. But the problem is that when you then train an LLM on billions of examples, all of those bad examples usually go into the training data, and then it just gets regurgitated. And in HTML, we've got more than 120 native elements. We've got more than 85 YARIA roles, and yet most people just define everything as a div. We've probably all seen buttons as spans or buttons as divs and all of that stuff, which from a visual perspective, and if you're using a mouse and clicking on that button and you've got an event listener for a click attached to it or whatever, that's fine. But if you're using a screen reader, then that translation of the DOM into the accessibility tree is completely different. So the roles matter, the attributes matter, because they all structure that accessibility tree in a certain way, which is what the screen reader interacts with. The screen reader doesn't read the DOM, the screen reader reads the accessibility tree, and that translation of the DOM into the accessibility tree is super important in order to get semantics, in order to get accessible names, in order for the screen reader to be able to know what it's looking at. And it probably doesn't help when a lot of frameworks now like to do polymorphic components. So a lot of frameworks now, like Material UI, for example, like there's a really easy way to just make one component another. You can just go, yeah, this is a button as a div, and it'll just ship that as that component. This obviously makes it easier to use the right elements as well. But if you're not aware of all of that stuff under the hood and you're just shipping buttons as divs, then you're going to have all of this these accessibility issues further down the line, and then all of that training data goes into the LLM, and the whole thing kind of compounds. I suppose thanks to this sort of stuff, it's never been faster to ship inaccessible components. So when we talk about the training data and all of that stuff going into the LLMs, they did a WebAIM survey, and they threw a tool called Wave at the top 1 million websites. Wave is, to be honest, it's an automated accessibility tool. It's not a bad one, but it's not great. It only finds around 30% of known issues. But of the top 1 million websites, thrown Wave at them, even though it only finds 30% of issues, they did find that the top 1 million websites has 94.8% of them have detectable WCAG failures based purely on using that tool, which has a 30% success rate. So if roughly 94% of the top million websites are inaccessible, that means probably all of that training data that goes in the LLM. So the LLM's looking at websites and it goes, oh, this is a good example of what HTML looks like. But actually, if 94% of those examples are inaccessible, then an LLM really doesn't know what good accessibility looks like. And I suppose this is detectable. Like if it can only find 30% of issues, we can probably estimate this is actually higher. Like if we looked at more than the top 1 million, it's probably, and we actually did an audit and dug deeper than just using Wave, we'd probably find that more than 94.8% of the web is inaccessible. So yeah, because 94.8% have been trained, there's far more bad examples than good, and those will always float to the top when an LLM is trying to cut corners. They don't want to burn through loads of tokens. They want to try and reduce the number of tokens that they use, reduce the cost, reduce the amount of computing power they're using. So they will always try and cut corners wherever they can, and that's why I suppose whenever you're trying to write custom GPTs and whatever, and you give it a whole bunch of instructions and then it just keeps ignoring them, a lot of the time it's just because the context window's a certain size and it'll just, wherever it can cut corners, it will. So then bad examples often float the top. There is ways around it, like a lot of companies are trying to favor certain, like of the training data, like you can weight certain things, so you can weight some training data to say this is more relevant than others and whatnot, but ultimately, if you just give it a whole bunch of stuff, it's going to learn from it. So some real world examples, and I guess just before we start, there is a caveat. So LLMs are being updated all of the time. This is the third or fourth time I gave this talk, and every time I try and update the examples, I have to take some of them out because they are getting better. So if you'd seen this a year ago, there was like loads of examples of them doing terrible things. As like every couple of months or whatever, some of these things do get fixed. And I guess if I gave this talk again in 3 months, I'd probably have to rewrite the whole thing again. So, writing text descriptions or alt text. I often hear people saying, "Oh, this is a really good use of LLMs. They can look at images, they can identify what's in the image, and they can write the alt text for it. So all of those pictures that people can't see or they have terrible alt text, we can now fix." And you can, for the most part. Like, this is something that LLMs are quite good at. They can describe images quite well, but it depends on which ones you use, and there is some nuance to it. So if we want to be inclusive and we want to be diverse, we have to be a little bit careful in terms of certain images and the way that we approach this. So I deliberately picked this image for the experiment. I gave it a whole bunch of tricky images. This one, I think, was a particular interesting one, because this is a stock image that I bought off Alamy. It's a transgender person, but it doesn't give you their pronouns. Nowhere in the image, in the metadata, in the description, nothing does it actually talk about the pronouns of this person. And gender identity is really important to get right. If we want to be inclusive, we don't want to misgender somebody, like that can be really harmful. And the stock image just described it as a young African-American transgender smiling confidently at street. So I was like, okay, well, how well are LLMs going to do with this? So the first one I gave it to was Mini CPM version 5, which boasted that it had better image recognition capabilities than ChatGPT. Granted, it's a bit old, and it is a one that you run locally. So if you're into cooking your CPU on your laptop, you can obviously run this on a local machine, and you don't have to use a cloud-based one like ChatGPT or whatever. But it did say that it was an African-American woman, and it says, it says wearing earrings and a smile. She is standing outdoors in what looks like a town setting, and buildings are behind her. So it's straight away it's decided, okay, this is a woman. I'm going to describe it as a woman, and it doesn't say anywhere in the image that is the pronouns that they use. This was Meta Llama 3.2 vision, which said that it was two young black men standing together in front of a background. So not only did it potentially misgender the person, it also, this is, I guess, a prime example of a hallucination. Like, the LLM was like, yeah, there's two people there. I did this multiple times, and every time I was convinced there was two people there. It is Meta, and Meta aren't known for being ethically great, so I'm not surprised in the slightest. But again, Meta Llama is a one that you can run locally. So the caveat is the ones that you run locally tend to be worse than the ones that run in the cloud. So I did give it a ChatGPT 5. First time I gave this a ChatGPT was version 4.0, I think, and it got it wrong. But now it actually got it right, and it starts to do it a bit better. But it says a smiling person with short hair, nose ring, and earrings wears a black t-shirt outdoors in a sunny urban setting with palm trees and a blurred building in the background. So it's now no longer potentially misgendering somebody, and it does do a better job. Claude's the same. So Claude and OpenAI tend to get this better. But obviously, if you're just using a local LLM to churn through loads of, like you've got a script running to write all of these things, just beware that the local ones tend to get this wrong more than the likes of ChatGPT. Another thing that I wanted to do was see if they could advise on WCAG standards. So if anyone's used the Web Content Accessibility Guidelines, this is ultimately what my day job includes a lot of the time, is just making sure that the interfaces we build on the web adhere to these standards. The most annoying thing about WCAG is that for accessibility standards, they're pretty inaccessible. Like, loads of people struggle to understand the intent behind them. They're like, is this a pass? Is this a fail? So the first thing that they often do is jump into something like ChatGPT and say, like, does this pass WCAG or whatnot? And the problem with WCAG, well, there's many problems with WCAG. This isn't a talk on bashing WCAG, but one of the issues that we have with it is that the same problem can affect different criteria. So depending on the markup and depending on what elements you've used, you can have a problem, but the problem can actually fail different WCAG criteria based on purely what that element is. So as an example, I have a link here, an anchor tag, and I have a button, and they both have no accessible name because the link only contains an image, and the image doesn't have an alt attribute. The button doesn't have an accessible name because it only contains an SVG, which also doesn't have an accessible name attached to it in any way. So these are the exact same problem, but they just use different elements as an example. And it basically means that if we have a link, it will fail 1.1.1 non-text content, 2.4.4 link purpose in context, and 2.4.9 link purpose link only, because links have their own special categories in WCAG for some reason. Everything else that's a button or a toggle or any other kind of control gets lumped under 4.1.2 name role value. So if we were going to fail the button, we would fail it under name role value. For the link, we would use the special link ones for whatever reason. Don't know why that is, but that's just the way that WCAG is. So I went to the LLMs and I was like, look, I've got a button and a link, neither of which appear to have an accessible name. Can you identify the problem, and can you tell me exactly which WCAG 2.2 criteria this would fail? And the first one was DQ's Access Assistant. So DQ are the ones that were saying they want 100% of all accessibility problems to be fixed without any accessibility knowledge. It got 1.1.1 non-text content, and it got name role value, but then it didn't get the other ones for link purpose. It might be a moot point, because if you did add an alt attribute to the image, then it probably would fix those other two anyway, but I asked it exactly which ones would it fail, and it couldn't tell me. And Claude was, this was ChatGPT. So ChatGPT was the same. It got name role value. It got non-text content. It didn't get the link purposes one, but it did throw in name role value. So it was like, oh, the link will also fail name role value. And that's not necessarily untrue. Like, it doesn't have an accessible name, so you could fail on that. It's just that links have their own criteria, and therefore we normally fail it on that rather than name role value. Claude did a whole bunch of weird stuff. So Claude found name role value. It didn't flag non-text context. It did find link purpose. And it did find link purpose link only, but it gave the wrong number. So the number should be 2.4.9 for link purpose link only, and it just duplicated the number from the one above. Then it also threw in headings and labels, and it's not a headings or labels fail. And it also threw in name role value, which we've said, you could add it, but it'll just add noise to the report, because we normally cover it under the link stuff. So if you're working to a standard, and you're trying to essentially say whether something is compliant with the standard, like 50% accuracy is really not enough. If you're auditing stuff, 50% is like, you wouldn't feel happy with a security audit if it was 50% correct. You'd be like, oh, I'm not shipping this because 50% is pretty terrible. But with WCAG, for some reason, we do. The next experiment was kind of restructure content. This is somewhere where I expected LLMs to do really well. Like, they know words, they know document structure. Like, this is somewhere where I was like, okay, they're just going to ace this. So what I did was I took the accessibility strategy from gov.uk, which has headings from H1 right down to H4. And it's a really long document, but I took all the headings, and they were like H1, H2, H3, H4, and then they go back to H3, and then down to H4. And then I jumbled them all up. I didn't jumble up heading level 3. I think that was just a mistake, but it means that the LLMs essentially got one for free. I think I just forgot to change it. But I essentially just jumbled all the heading orders up. And then I gave the document to the LLMs along with, they got the whole context. I obviously can't fit it on the slide, so you've just got the headings, but they had access to the whole document. So they could read it and hopefully work out where their headings go. ChatGPT only got the first 3 right. Obviously, I gave it the third one for free, so maybe it only got 2 right, I don't know. But it went wrong on the 4th one. And once it went wrong, it couldn't recover. Like, all of the heading levels below that were then out of sync, and it could never really quite find its way back to restructure the document properly. I did the same thing with Google Gemini, and it did the same thing. It got a little bit further. It got down to the, what did it get right? 5 of them right, and then it went wrong, and then again, it couldn't recover. They were all wrong after that point. Again, Claude did something a bit different and a bit weird. Claude got the first two right, got the third one wrong, even though the third one was right when I gave it to it. It changed it to a H2. It then got a few wrong, and then it managed to get back on track, and it did get the rest of them right at the bottom. But the problem is by changing the third heading to a H2, these subsequent headings were now grouped technically under the wrong, in the document they were under the wrong structure, so they'd kind of grouped it with the wrong information. So although it recovered, it still kind of broke the document structure. And the last test was kind of fix accessibility issues that occur in the markup. So I gave it some boilerplate code. This was a full HTML page, but again, obviously on the slide, I can't fit it all on. But there was a HTML tag at the top, which had language EN on it for English. And then the problems that we had was that the heading is outside of the main tag. So if somebody is navigating using a screen reader and they jump straight to the main tag of the page, there's no heading in there because the heading sits outside of it, so they would miss the context for what it was they were looking at. Also, English does not read left to right, but does not read right to left, but there is a right to left direction attribute on there, which tells the screen reader this is a right to left language like Arabic or whatever. And then we've got an additional language EN tag on the paragraph tag. So the EN tag is essentially redundant because the language is already set, but then we're setting the wrong reading order for the reading direction for the language, the paragraph, sorry. So DQ's Access Assistant didn't do particularly well. It said the language attribute is correctly applied to the P tag, which is good. It's not, because it shouldn't be there. It then got the next one right. It was saying, however, the text is in English, so therefore it should not have the right to left attribute. Then it said the correct solution to fix it is to change the right to left attribute, right to left to right. So it essentially said this is how I should have fixed it, which actually we should have just took the attributes off because they're completely redundant. So it's not necessarily that this is an incorrect solution. Like this probably would have worked, but it's just adding bloat to the code base and it's increasing the likelihood that something will go wrong because screen readers and the way that browsers implement things can be tricky. We can sometimes get bugs. If you're just applying redundant attributes, you don't know if it's going to break something or not. It's better just to obviously do it the common way and not have it in. Claude did a bit better. Claude did find the right to left problem, and it did say that the extra language tag, the extra language attribute was redundant, so we could take it off. But it did incorrectly say that the main element is outside of the H1, which is the wrong way around, because the H1 should be inside of the main, not the main inside the H1. I did ask Claude to fix the problem, and it did fix it correctly. So it knew what the problem was, and it did fix it. But when it told me the problem, it told me it the wrong way around, which means that if I'd went away and just implemented it myself, then I probably would have implemented the wrong solution. So it's not necessarily that Claude was incapable of fixing this, but it did explain the problem incorrectly, which could have led to the wrong outcome. And this is, I suppose, again, just highlights some of the shortcomings in the way that these things, you can't just take them at face value. You do have to kind of sense check what they're saying. The biggest question that I have is if LLMs could truly write accessible HTML, why aren't any of their own UIs accessible? So if we go to something like ChatGPT, and we just run an automated accessibility tool like Arc, it has a whole bunch of accessibility issues in it. It uses ARIA attributes it uses duplicate labels. It uses insufficient text contrast. It finds there's a bunch of stuff in there which is very easy to find, but it is fail on WCAG. So if it can do accessibility, why doesn't it write its own code and do it properly? It's the same with Claude. If we run the same tool on Claude, we get a whole bunch of errors. It's using ARIA attributes on elements which aren't allowed to take ARIA attributes. It's using, there's elements that, it's using ARIA hidden on a parent element, but the attribute the nested element is still focusable with the keyboard. So there's like a mashup of what you can target with a screen reader versus what you can do with a keyboard. There's a whole bunch of, these are quite easy things to find and fix. And Perplexity is the same. So it's just, they've all the big three, I guess, have a whole bunch of issues on them. And it's like, well, if it can write HTML and do it well, why isn't it doing it that well? And then getting into agentic AI. So this was all kind of just done with prompting AIs within in the browser or in the sort of desktop applications. But agentic AI obviously chains together consecutive prompts autonomously to achieve more complex goals. So instead of it just being a back and forward, like I ask you one thing and then you tell me one thing, and like now I can ask it to do something, and the AI can obviously chain together all of them prompts and do 20 or 30 step processes to get to an end goal. And accuracy decreases with complexity, and accessibility is complex. So there's a lot of stuff that we want it to do, but every time we go down a new step in the process, the likelihood for it to go wrong increases. And this is called error compounding in LLM agents. There's a whole blog post on it by Utkarsh Kunwat. It's basically talking about why. So they've built a whole bunch of LLMs. They've built a whole bunch of LLM agents, and they're betting against them being the future of how this technology works, because there's just a mathematical problem with the way that these things work. So if we look at, if you had something that was capable of producing 99% accuracy on one step, at the moment we know LLMs aren't there, we've just seen a whole bunch of examples they got wrong. But if you were somehow able to create one that 99% of the time gave you the right answer, if you take 99% and you do 20 steps, the likelihood of that 99% on every step, you're only at 82% accuracy by the time it's done 20 steps in a row. Realistically, if we look at LLMs being maybe 95% accurate, they end up at 36% accuracy after 20 steps. So that whole sliding doors moments we were talking about, where they've got the potential to get something wrong and not be able to recover from them, the more complex the process and the more steps you make it do, it's just a mathematical probability that the likelihood of it being correct at the end is going to go down. And I suppose with some of the local LLMs and whatever, they're nowhere near 95% accuracy. So as soon as you're getting them to do autonomous things, that whole idea of getting something good out the end is a bit of a pipe dream. The LLM token economics also doesn't scale. So you've got this idea of, if you have a back and forth around 50 turns, you're looking to pay about $2.50 for that exchange. As soon as you get up to 100 turns, which is just double the amount, the cost's now over $100. And it's like there's this sort of hockey stick of complexity where as soon as you can get it to do one or two things. I don't know if anyone here uses Claude Code, but what you'll often find is if you track your usage, when you first start the chat and you start asking it to do stuff, the usage is just creeping up like percentage by percentage. Once you've got a context window full of stuff and you've got a whole bunch of complex things and you're having to edit multiple files, every time it does anything, you see it jump by I've seen it jump by 25% in one turn once, because it's just trying to crunch so many tokens to understand what have I done before, what am I doing now, what are the requirements, what have I done previously, what do I need to edit. So this idea of just chaining more commands together, mathematically you're unlikely to get things out the other end, but also the cost of it's just going to go up exponentially. So I think AI is potentially just like this, another iron triangle, if you've heard of this term in product before, but it's basically like you can have something that is cheap and fast, but it's probably not going to be accurate. You can probably have something that is going to be cheap and accurate, but it's probably not going to be fast. Or you can have something which is fast and accurate, but it's probably not going to be cheap. And I think when we talk about agentic AI and its ability to do accessibility and its ability to do all of these complex tasks, is ultimately what it's going to come down to is, how much can we ask it to do? How much are we prepared to pay for it to do it? And how much work are we going to do at the other end to make sure that what it's done is accurate? Because just assuming that it's okay and shipping it, we've just kind of seen you're probably going to ship something which is going to have issues in it at some point. So I think for me, and this is all my opinions, but I think so far AI has overpromised and underdelivered. I think many organizations have fired developers. There's news of them now trying to hire them all back. I think Amazon's just said that it's trying to hire 11,000 developers after laying off 30,000 people. So I think there's a whole bunch of organizations that have went all in on AI and sacked their workforce. Now they're like, oh, actually, this thing isn't as great as we thought it was going to be. From these examples and from my use with them, they do struggle to use HTML5 to spec. They regurgitate bad markup, which are riddled with accessibility issues. They use ARIA attributes on elements where they're not allowed. Like, the spec is available for it to use, but it just doesn't use it for whatever reason. And I think whenever you use something off-spec, it's not necessarily that adding an attribute to something that doesn't take one won't work, but it's just if we want things to be consistent and a consistent experience, we need to work to these specifications. And yeah, I think like they will confidently tell you that something is accessible when it's not. You can basically say to Claude, like, is this code accessible? It'll be like, yeah, great. And actually, it's full of issues. And organizations are responsible for what they put out. Like, if you end up in court because you failed to comply with the European Accessibility Act and you're selling products to customers in Europe, if you end up in court and you're just like, oh, it's not my fault, like, it's all Claude's fault, like, that's not gonna fly, like, they ultimately are gonna hold you accountable because you're the one that put it out there, even if you're not the one that wrote the code. So if you are if you're selling to customers in Europe, if you're working in somewhere like the UK, which has the public sector bodies accessibility regulations, there is laws and legislation that governs how that something has to be accessible. So just churning out AI slop and hoping for the best, like, could land you in hot water. And I think we need to use LLMs for what they're good at. We need to do very specific technical tasks with very testable outcomes. As soon as we start trying to ask them to do sort of broad things that require a lot of subjectivity, like, audit this thing against WCAG, when WCAG itself is quite subjective. Like, I might think that a link describes topic or purpose, and you might not, and therefore we would audit that result differently. Those kind of subjective things are where LLMs really trip up, because their level of confidence or their surprisal score doesn't allow them to just be like, yeah, this is a testable thing. If it's writing code and it's able to write a test that validates the outcome, then you can rely on it a lot more. But asking it to do woolly things is where they kind of really trip up. And spend your time planning the prompt before you actually prompt it. And I found like a lot of people just go, oh, this code's not working, I'll just copy and paste it into Claude and off I go. It's like, actually, if you think about what it is you want to achieve, then you say, okay, I've got to rewrite this feature to do X. Spend like half an hour up front writing requirements for it. Do like spec-driven prompting, like write requirements, have Claude come up with a plan, have it write a task list. You can have it write in a human-readable format, so you can see all of the steps that Claude intends to do before it does it, and have it break it down into steps of 5. If you break it down, say, okay, execute phase 1. In phase 1 is only 5 tasks. It'll execute phase 1, and then you can go and look at the diff and see what it's changed, and it becomes a lot more, like, everything's at your pace and under your control. Whereas if you just let it run off and do 20 steps and it changes 20 files, and now you've got all of this stuff to look through, it's going to be more likely that you'll miss something. And it also means it's going to be more likely to get it wrong. If it's only doing 5 steps at a time, that's a lot shorter of a window. Like, if something goes wrong on step 3, you can catch it at step 5. If something goes wrong at step 3 and you haven't told it only to run 5 tasks and it runs 20, there's a lot more to unpick. So I think if we're using these tools, like, spend a lot of time. Like, if it's like that idea of some people think about a problem for a day before they actually work on it. And I think it's the same for prompting. Like, we really need to think about what it is we want to get out from it before we just dive in there and start telling Claude to go and edit all the files. And I think this is kind of the crux of the whole talk, I suppose, is like, we know human-centered design because we are human. Like, Claude doesn't know that. Like, AIs just see code, but we see people. And an AI can't sit with your users. It can't feel their frustrations. It can't look into their eyes as they're telling us how this thing doesn't work for them because they use a screen reader, for example. Like, Claude will happily just look at a problem as a thing to solve with code, and it'll just churn it out and then tell you that it's done. But actually, I think, like, I've been guilty of this in the past, where we'll do anything but talk to users. We'll look at analytics, we'll iterate things, we'll A/B test things, we'll do all of this stuff, and actually the solution is often just to sit down with people and watch them use something and see what they do. And if they can't use it, it becomes very obvious. Like, you can have something that's WCAG compliant, but it's completely unusable. Or you can have something that is not WCAG compliant, but actually works for everybody because you've sat there and worked with them to get it to that point. So I think for us, like, our competence is our relevance. I think like anyone can churn out AI slop, but few people can truly build inclusive products that work for everybody. And I think when we talk about AI, like if you're a developer that's worried about AI taking your job, if you're an accessibility specialist like me who worries about AI being able to do all things accessibility, like at the moment it can't do it, and it looks unlikely to be able to do it because the training data isn't good enough. So I think for us, understanding our standards and doing our craft well is probably the place where we stay the most relevant. And I think we can get anybody, can learn to use the tools and we can learn to use them well. But if we can't assess that the stuff that it's putting out the other end is good, then we're just compounding the problem because that'll go back into the training data and everything will just kind of snowball. So yeah, I think as long as around 94% of the web is inaccessible, this is definitely a place where we can still stay relevant. But that's everything for me. I appreciate it's over a little bit and we're running behind time, so apologies, but thank you.